Just for the record, I'm also with the EthPandaOps team. But yeah, it's part of the EF. So today I'm going to be talking about Fusaka, what we have done in the past year and a half. Fusaka has actually been Pactra B, which basically means that we wanted to have PureDAS in the same fork as Pactra, but then it started to grow so big that we just didn't see it as a viable option. We decided to take the headliner topic, which is PureDAS, out into the next fork, and that is what we are going to talk about today. So Fusaka brings a bunch of other EIP improvements also, scaling the L1 and the DA at the same time. This includes the topics that Marius talked about earlier today, raising the gas limit to 60 million, basically limiting the maximum block size to 10 megabytes, ensuring that we can scale the L1 as efficiently as possible. We introduced the name of BPOs, so this is basically a light fork. We're going to be able to increase or decrease the target and max blob count without needing to we can do a hard fork without much organization from the client teams. Like, we are not changing anything other than the blob counts. Then we have a bunch of repricing EIPs. We don't have enough time to go into each of these independently, and we have a new opcodes that improve the UX, and the pre-confirmations are going to be enabled by deterministic proposal look ahead. So how could we actually manage to ship 2 forks in 1 year? This was just because we started to work on PureDAS very early on, and we were pipelining shipping of PureDAS from Kenya last year, which was around May, if I recall correctly. We had parallel work on Pactra and Fusaka. In the meantime, we had CL devs, one CL dev from each team, working on PureDAS pretty much for like the past 12 to 15 months continuously. The first PureDAS implementation appeared in June of 2024, and without having a dedicated person from each client team, we would have not been able to ship 2 forks in the same year. From this, maybe we can talk about PureDAS and what is PureDAS. So currently today, every single validator downloads every single blob, and this blob is then going to be served to the whole network. Going forward, if we want to scale up the number of blobs, what we have to do is, while keeping the network decentralized, we have to make sure that each blob can be split up into a smaller section so that small validators can actually still validate the chain, propose blocks, while bigger validators will actually take over the load of the heavy lifting. So if you have a small stake of like 32 ETH, for example, you're only going to need to custody a few sections of all the blobs, a few columns. This column is a new concept, and this enables us to split up the load in the whole network. While the larger operators will actually have to have an increase in resource usage. This means a bit more compute, a bit more memory usage, and significantly more bandwidth usage. This will enable us to have a larger blob capacity while keeping the network decentralized, and more blob capacity will enable L2 scaling and cheaper transactions for everyone. What is actually under the hood of Pactra? So, as I mentioned in the previous slide, blobs will be split up into columns. The nodes will have to advertise how many columns they have available. So this is introduced under a new field called the CGC, the custody group count. The columns will be then propagated to the relevant nodes. So a specific column will only go there if that specific node needs it. And the columns then also can be reconstructed to save some bandwidth. So if you have 64 columns, for example, you can just reconstruct any columns in the network. Nodes with over 2048 ETH will become the super nodes only. So if you don't hold 6.4 million on your home machine, then you probably don't have to worry about this. But some node operators, such as the Lido CSM operators, will actually have an issue where they don't actually hold the funds, but they stake on behalf of someone else. So their resource requirements will be actually increased. But yeah, we assume that significant part of the supernodes are expected to be sophisticated entities that will have the resources to run these heavier nodes. So what actually helped us achieve testing? We have a bunch of tools. You probably heard about Dora. We had a peer desk column custody overview, which enabled us to oversee which node custodies which column, and this gave us a very quick overview on just debugging in the network. Like if we expect that a node is a super node, then we want to make sure that the super node will show up in all of these columns, and if we have a non-validating node, then it would show up only in 4 separate columns. This also helped us debug peering-related issues. We also added Desk Guardian. This was a collaboration with the
Probe Labs.
They helped us build this tool, and then we integrated it into Dora as a library function. Basically, the main fields are the new earliest available slot and the column custody here. So this helped us a bunch to debug early issues with different CL teams. What else? We also added EthConfig support into Dora, so we can have an expected config value on one side and the actual client, what the client is reporting. This doesn't seem like a big thing, but actually clients like to just configure their clients however they want instead of whatever the spec is saying. So this really gives us a very easy way to see if they messed up something. This is also working now for the EL. And Thinker. So Thinker was built by Rafael from our team. Thinker enables us to basically run a sync test, let it be a checkpoint sync or a Genesis sync for super nodes or non-super nodes, and it gives us statistics on how long the sync has taken. And we run this on many times. So for example, on our DevNet tree, we have run it over probably 100 times to see how the state grows and if we have any syncing issues altogether. And I will pass it to Pari.
So I'm going to talk about what else helped us test it. So another tool was Spammer. So Spammer was a tool we had that we can configure a lot of custom scenarios on. And these custom scenarios can be real-life transactions, so similar to like Uniswap transactions or blobs that we expect L2s to submit. We also want to talk a bit about why it took so long. So what was the requirement? Why was the requirement changing that took 15 months to ship PRDAS realistically? Even though it feels like a 6-month fork, it only is a 6-month fork because we pipelined it. Well, the core EIP was implemented relatively quickly. However, we went through multiple rounds of bottlenecks that we found. One of the bottlenecks is that it takes about 100 milliseconds to compute proofs for a blob. And this is fine if you have like 6 blobs, you can afford that. If you have 40 blobs or 72 blobs, which is a theoretical max of the design right now, that doesn't work anymore. You have a 4-second attestation deadline and you need to takes 7.2 seconds to even generate the proofs. That just doesn't work. So one of the bigger solutions was to move the cell proof computation during the time the transaction is being sent. So your transaction, the blob sender will take slightly longer to submit the blobs, but in the critical path of the chain, we no longer see this problem. This took a bunch of time for tooling support, for client support, RPC support, a lot of discussions about how to maintain backward compatibility and so on. So this was a huge topic for us. There was also a lot of peering issues, which you can expect in a networking change. One of the larger ones was that if you're trying to request columns from an older node that's recently joined the network, you tend to ask for something they might not yet have. And you don't know necessarily if they have it or not, so you're unnecessarily penalizing them. The solution for this was to add some information such as earliest slot, so the client can actually say, hey, I'm your peer, these are the columns I'm custodying, this is the slot that I have data up until, so don't try to ask me for something outside of this, and don't penalize me if you do so. So this helps a little bit with especially non-finality scenarios, because when you have a non-finalizing network, there's a lot of nodes syncing at the same time, and it leads to these weird edge cases that are just very hard to recover from. Since we've deployed this, non-finality scenarios have been quite good, actually. And if you're interested, like Fusaka DevNet 3, even today is going through a non-finality test, but we're, I guess, so confident about it, we're here on stage instead of actually looking at if the test is successful or not. How much can we even scale, right? So the next big question is, we have PeerDAS. We know the theoretical max of the system. We've found a couple of bottlenecks, but what is the actual scaling that we're going to ship with? Were we going to go from 6 blobs to 72 blobs immediately at Fusaka? That was the original idea, but the longer we looked at the problem, the more unsafe that felt. That's why we introduced the concept of a blob parameter-only fork. This essentially says, don't change anything about the fork, just change the blob number. And so far, we've defined about 2 BPOs, and we have a plan to define another 3. And this allows us to do it stepwise. So we can do minor changes, deploy a networking change, probe the network, see how it reacts, and then do a bigger change. The reason this is also important is, as much as we can define devnets, we can do 1,000 node, 10,000 node devnets, the problem is mainnet is always deployed differently. However, a certain staker chooses to deploy their node will go into the peering logic. And there's no way of accurately simulating that, at least not today. And that's why we wanted to go with the safer approach. And the next question is, what is the right number, right? We chose that we want to go to a safer approach. We chose that we want to split it up into steps, but someone has to still find out the step and find out how to find out the step. And this is where the Zatu tool from our team comes very handy. There's a concept of a Zatu sentry, and this connects to the Beacon API. There's also a concept of client forks that we maintain, and this is allowing us to get very deep visualizations into the peer-to-peer layer. We also have contributor, which if you're a home staker, you should be running. This will collect as little information as we want from you, and this will tell us how timing variances work in mainnet. And all of this will go into analyses that give us insights into what our blob scaling numbers could look like. We also want to give a shout out to Sunnyside Labs. We did really large networks, probably the largest we've done before. We did 2,000 node networks alongside with them. For a scale, there's about 10 to 20% the size of mainnet. So that's probably the largest we've done in a while. We had to do a ton of optimizations to even get there without everything just out of memorying. And this leads to this beautiful blog post done by Sam. If you ever have doubts about how we reach our scaling targets, please talk to him about how he's analyzing the data. You can see a clear trend where the blob count looks quite good at the lower we go. And the higher we go, it looks iffier. And that's why we aren't immediately announcing a jump from 6 to 72. Rather, the next 2 BPOs go all the way to 21, where even from the time where this graph was taken, we have a lot of optimizations already put through. So we don't imagine any issues immediately. And then there's another whole round of optimizations that will get shipped, like partial cell proofs. There's a lot of peer-to-peer optimizations that go in that make us feel more confident that we can then schedule the next tranche of BPOs shortly after. There's also the Syncor tool, and this was very important for us to actually figure out, hey, if we go to 72 blobs and we have a home staker with 50 Mbps internet, are we going to make them take 4 days to sync? So this sort of helped us try out full sync, supernode sync, as well as varied number of blob targets and non-finality, and then throw all of this into nice dashboards and figure out, okay, this looks like a reasonable target for now. And in general, the phase is you have a testing phase, you do these 2,000 node devnets, you have an estimation phase where you collect all of this information, you look at it, you then schedule a fork, you enjoy the scaling for a bit before people complain that scaling is saturated, then you optimize and repeat. And this is the loop we want to introduce for BPOs in the future, and it's something that's going to keep happening over the next years. And that's our talk, and we're happy to answer any questions you have about Fusaka. Thank you.
For the supernodes,
Yes.
how do you actually calculate that there's 2048 ETH on a machine? Is it like keys in a certain validator client? So if you ran multiple clients, could you stay below that threshold?
So when the validator spins up, it registers itself with the beacon node. And then based on these registrations, you would know how much stake you're custodying. And then that goes into the beacon node's information of how many columns it needs to custody. So you could take your one validator client and then spread it across, let's say, 20 different machines, each of them just touching one beacon node, and then you would have lower resource use. But the argument is if you have 2048 ETH, it's probably better for you to have it pointed at one beacon node or a few for redundancy rather than kind of chunking it into smaller ones.
Yep, sounds good. Thanks.
Yeah.
And it's based on the effective balance, not the validator count. So
Yeah, that's true.
It doesn't matter if you have one validator
Yeah.
with 2008 or, you know.
Yeah, from the perspective of the protocol, we just care about how much ETH is staked, not necessarily the validator keys themselves.
And this value only goes up. So we made this change later on, like around July this year, where the CGC value of a beacon node will only go up, so that even if you start removing validator keys, the beacon node will not decrease its CGC value. This was an optimization. We decided to go with it. In case you just want to reset your CGC value, all you will have to do is remove your database, start fresh, checkpoint sync, and then point one less validator to that beacon node.
Okay, I honestly have a shit ton of questions. I don't know which one to select. Let's keep at this topic of a supernode.
Yeah.
So we have two things. We have this PeerDAS where we are saying that 2048 ETH is a supernode. At the same time, we have people saying, hey, you should consolidate.
Yes.
Which means that with the consolidations, 2048 is just one validator.
Yes.
And it's already a supernode.
Yes.
Exactly. But
Okay.
that's why from the perspective of the protocol, it doesn't matter if you had 200 validators or whatever the number works out to, split with 32 ETH each, or you had one validator with all of that stake.
Yeah, that's understandable.
Yeah.
Okay, now to BPO schedules. So
Yes.
you said that 2 are already scheduled.
Yep.
Does it mean that they are now inevitable?
No. So that's also why we have a bigger gap between the BPOs, so that we can actually look at the network, analyze if the performance is degraded, if it has, if we have to ship any optimizations, and we still have the option to cancel a BPO. We just reschedule it.
Yeah, so the question that scares me more is not network immediately degrading after a BPO, but BPO coming out we us not seeing a real increase in demand. So if you raise limits, but the actual consumption is never raised, and then you raise limits one more time, you've basically never tried the thirst limit.
Exactly. So the solution there is for us to pay a bunch of money to make sure we're hitting the limits, at least for shorter durations of time, so that we can probe the network at the limit.
Thank you very much for that.
Blobs are surprisingly cheap, so we can afford to saturate them
Yeah,
when
now
it's
as,
important. for
now as a
scaling.
CSM validator and my almost super node, your test's gonna cost me a bit of a gigabytes on my drive.
Yep.
Okay, thank you.
Yeah.
Thank you. Just one last question here because we are at time for it, but I don't think your talk specifically covered it, but let me ask you, which is Fusaka is scheduled, I believe, for December 3rd. Is that correct?
Yes.
And a lot of the conversations both yesterday and here, is it definitive? Is it going to happen? Is there anything that's going to stop it, or is it December 3rd?
So the client releases are already out. The blog post has been shipped. So unless we find a mainnet breaking incident in the next couple of weeks, it's scheduled for December 3rd.
Okay, perfect, perfect.
As well as the BPOs, like as we mentioned, 2 BPOs are already scheduled. So the first BPO will be happening on the 9th of December, and the second one is, I believe, around the 7th of January.
15th.
15th of January.
Yeah, but that's why please update your nodes. The moment you notice anything funky, let us know. We will be probing the network, making sure everything looks good, but the more the eyes, the better.
Barnabas and Perry, thank you very much for an excellent presentation.
Thanks.